Are we ready?
Here are these.
Is that yours? Anything left there? The heading isn't right on this. I want you to get your points. So I know who this is. You're going to lose if you don't do this heading and folding right. You lose points. Okay? It just takes a little concentration. Okay. Exam is tomorrow. So if you go to quizzes and exams in Blackboard, if you go to quizzes and exam in Blackboard, you'll see exam 1 and associated quizzes. This is what I put up last week. It's still there. So let's talk about what's on the exam. Okay, everything we've done so far. Ideas and meanings of multiplication and division. Okay? Representing visually how two quantities covary together. And we did a lot of bar diagrams, right? And then we talked about how bar diagrams become XY graphs when you flip up the second bar vertically. Okay? Representing covariant quantities symbolically. Function notation. Okay, this is huge. And this was a big part of this graphing calculator packet worksheet that you did, was practicing function notation. Okay? It's absolutely key that you can look at notation and know what it means. And then, given a situation, you can use it. You can apply it. Okay? So lots of that. We'll review that today. Okay? Graphing calculator. Questions about graphing calculator is on the exam. Okay? Because graphing calculator the instructions that you give it are all the exact same mathematics that we're using. So I want to see if you've learned that mathematics in the context of graphing calculator. So representing functions on graphing calculator. Graphing lines, functions, and points. And then sliders. Okay? So you're not going to bring your laptop and use it. Okay? It's going to be questions about command lines and maybe you writing some command lines. Okay? Or analyzing, given command lines, you're analyzing and you're saying, what is it doing? Did that answer the question, the hand that went up? Yeah, okay. So yeah, so you're not going to have graphing calculator with you, but it is definitely a good portion of the exam. Okay? Constant rate of change. So we've started talking about constant rate of change, and the 3 guises in that packet chapter that you've been answering reflections. Okay? So there's nothing on the exam that doesn't fall under one of these categories. Okay, so we've had one quiz. I've put up a blank version and the solution key, and that was about the horizontal bars. And then I've also posted in assignments, except for today's, which I'll post later today, I've posted solutions. So you'll see a new link, solutions, photo 1 answers. Okay, that one doesn't have solutions. We're going to talk about that today. And this one, there's one more thing I'll post. Okay, so along with the assignments that are still posted there now, I've posted some solutions and answers for you to go back. Okay, so how do you study? Homework. Okay? Videos. Okay? There's nothing on the exam that we didn't give you some kind of homework about and then also emphasize in class. There's nothing on the test that wasn't emphasized as important in class. Okay, so that quizzes and exams, that's the centerpiece, this bullet list. And you're working through homeworks and videos and keeping this in the center of what you need to understand to do well in the exam. Any questions about exam 1? Oh, so logistics. It's tomorrow. It's in the same place that you took the pre-test. So it's in this building downstairs. They open at 10:30. You need to be in the door by 6:30. Okay? And then you can work until 8:15. Yeah, so as long as you want to take the exam, you can use a calculator. Okay? But lots of the questions don't involve a calculator, but you can have a calculator. What else? If you would, make sure when you make sure you're sure what your last name is and your first name. So when you bullet on the Scantron form, when you bubble in your name, make sure you're getting your last name correct. Okay? And then your first name correct. In the past, there's been several who switched these. Okay? According to how you are registered at ASU, make sure you know what your last name is. And put that here, and then first. And then don't forget to bubble in your ID number also. There's no special code, but your ID number, and make sure you get your last name correct. Yes?
You said in an email before the pre-test, you talked about extra credit for it.
Yeah.
How is that going to work?
So here's the thing with Blackboard. I get lots of emails. You go to Blackboard, you look at the grades, and then you're getting the feeling like these grades are different than what he said in class, okay? Or the way it's formatted. I don't use Blackboard to compile or total any grades. All I use Blackboard for is to record individual scores, okay? So anything that says a total or an overall or a percent, just ignore it. I only use Blackboard grades to record individual scores. So you got a score out of 25 on the pretest. That score will be, depending on how well you did, that will earn you some bonus on this exam. Okay? But you won't see that on Blackboard. All you'll see is your score out of 25. But I promise, I'm not going to change my mind. Okay? You will get, if you got over 15, you may get a little bit of some amount of bonus. Over 20, another amount of bonus. Over 10, another amount of bonus. You just won't know for now. Okay? Does that answer it? Other questions? Yes, sir?
About how long it would be?
Oh, I would say the average is going to be about an hour. I would leave yourself an hour and a half, especially if you know you want to take longer on an exam. Leave yourself plenty of time. But I would say the average of all of you will be about an hour, hour 15. Yeah?
Is the test on multiple choice?
No. It's a lot of multiple choice, and then there's a short section of free response. Okay? But the fact that it's a lot of multiple choice does not mean, those of you who have had me in the past, does not mean you have to understand it any less. Okay? You have to understand it just as well. Do not study less because I just said there's some multiple choice items on there. You've got to know it, okay? I am a master at writing a good multiple choice test to see if you know, okay? I'm not afraid to say it, okay? Study just as hard as if it was free response, multiple choice, matching, whatever. So you're going to study just as hard, okay? Other questions? The test is challenging, okay? The test is challenging. So you got to know what you're doing. You got to really know what we talked about and understand it well. So on that point, let's talk. First, let's talk about some graphing calculator and functions. So here, I've entered S of k equals k plus radical k. Okay? Can you read that in the back? Is that big enough? Thumbs up. Okay. So I've entered this S of k equals k plus radical k. And my question is, given this function defined, this function called S, the name of it's S, what is the role of k? What is the role of k? So get a partner and see, could you explain, what's the role of k in this function? And I'm going to get the roster up. We're going to call on you by name today. Go. What does it do? What is it? Okay, where's Megan? Any idea, Megan? What's that? K is the input. And how does it relate to the function then? If it's the input, so whenever we invoke the function s from here on out, whenever we do s of something, what's it going to do with that something? What's it going to do with that something? Elizabeth? Yeah, it's going to take whatever's in the parentheses and it's going to do this to it, right? Yeah, so it's going to evaluate the rule for whatever's in the parentheses. Okay, k is called a local variable. There's nothing special about an association with k and the function s. It's just what we chose in that line to be the input on which we're going to do the instructions. Okay? The instructions are take the input and add the square root of the input. That's what the function says. All right, so if I were to type in s of 3, I'm going to type in s of 3 into a command line. What's going to happen? Am I going to see a graph? Am I going to get a number? What's going to happen if I type in s of 3? Graph? What number? 4.733 plus the square root of 3. It evaluated the function at 3. Okay? I'm going to put in s of a. What's it going to do if I do s of a? Is it going to graph it? Give a number? What happens if there's a parameter that we haven't defined? Yeah.
Doesn't a just equal 1?
If we haven't defined what the parameter is, then a is 1. So what will it do? What's it going to say? Which is? 2. Okay. If we haven't told it otherwise, a is 1, and now it's evaluating s of k at a, and it's going to say 2, right? Okay. What about if I do y? I'm going to say y equals s of 4. I'm going to do y equals s of 4. What's it going to do? What will it graph? Lots of you saying a horizontal line. That's right. It's going to graph horizontal line. So don't have graphing. Don't do this before I answer the question. So think about it. Don't just type it in and see. The point is to think about and know ahead of time what it's going to do. So don't preempt me with your own graphing calculator. So it'll graph a horizontal line. At what horizontal line? What horizontal line will it graph? Y equals 6. Why? Because what did it do? It took s of 4 and did what? Evaluated it 4 and graphed y equals that value. See, s of 4 is just a single value, and when you graph a single value, you get a horizontal line. Are we good? So the question is, how do I graph? I want to graph this function. I want to see this relationship between input and output if k is the input and the output is k plus radical k, and I want to see that relationship. How do I get that graph? So x takes the role of, it's like a spray. It's like every x value that's defined on the x-axis, it's going to put into the function. All of them at once. Right? Not just a single x. Oh, Owen. So what I need you to do is, we need to give those homeworks back to them at the end of the class. So you just, what's that? Yep. So it's just a quick completion grade, and we're going to give them back. And that'll be like attendance too. Does that work? Thanks. Okay. So so x is like all of the x values at once. And so if it's put into a function, it's going to put all the x values into the function at once, give out all the outputs, and show us what all the corresponding ordered pairs is, which is the graph. Good? Okay. All right, what if I do this? Now I'm going to put in S of x equals k plus radical k. What's going to happen when I hit graph? Talk to your partner. So what's going to happen when I hit graph? What's going to happen? Talk to your partner. Okay, this Lauren. What do you think? Yeah.
If it does graph, it's going to have a
Vertical
vertical line at 2.
line at 2. Draw it with your finger. Draw it with your finger. Okay, so you think vertical line at 2. What do you think?
I don't think it's going to graph.
Not going to graph at all. Any other suggestions? So, in this line, what does the role of k have? What is k? So here is a local variable that's just telling us what the input is and the set of instructions for the function s. But in this line, k kind of is different. What's k here?
Constant number.
What's that?
Constant number.
It's a constant number. Have we defined it? So what is it? 1. So is that why you were saying 2? Okay, so she's on the right track. This is going to be 2. So it's going to be s of x equals 2.
It's just
Horizontal line where?
2.
At 2. I thought. Or nothing. Yeah, so we didn't say y equals. Okay. So yeah. Okay, so the point is in this case now, k plus delta k, it doesn't know anything about s of x. It's not graphing calculator is not thinking s of x, it's thinking, oh, this is some parameter k, and it hasn't been defined, so by default, we'll make it 1. So therefore, 1 plus 1 is 2. Okay, so this, did some of you, when you did the third part of the homework, so this was the third part of the homework that you were going to have saved on your computer, or you emailed it to me. Remember this? Did some of you do this and get a horizontal line?
Yes.
So
Vertical line.
you got a vertical line. Okay. So here's a common mistake, is to create the function b like this. Say, oh, I know I'm going to graph capital N, so I'm going to put x there, and then I'm going to set it up like this.
Everywhere Andy changes to X.
No, it has no idea. Everywhere there's an n, it has no idea you meant this was n. That's the point. You see? There's no, you're not telling it at all that this was n. You're just saying it's x. So what is it going to consider n to be here? 1. It's just going to plug 1 in for n. It's going to have no way of knowing the connection between this fourth input and this needs to be the exponent. So if you set up the function this way and try to graph it, you're just going to get a horizontal line because for every x value that is put into this, all these other things are constants. It's just going to be whatever that constant number is when n is 1. So what do we need to do? How do we need to change the function? We need to tell it that what's in this fourth space, this fourth input, is actually what we want to be those exponents in that rule, n. And now, when we tell it to graph it, now we're telling it, let the n variable be x, be a bunch of x's. So, it's the great thing about graphing calculator, it's the instructions you give it are purely mathematical. We're not typing instructions to draw this pretty curve. We're just giving it the mathematics, and it's obeying us. So it's really great test to see if you understand how functions work. Questions on this aspect of graphing calculator? Okay, and so then we had the assignment for today, the packet. So if I want to graph this easily, I do y equals a of x, right? And we know that we wanted that between 0 and 110. Pretty good picture there, okay? We learned how to graph points. How do we graph points? Control 2. So if we want to make sure we have a point, we want to use the slider to get a point on the graph. We want our slider parameter to be the x value. And then how do we get the corresponding y? A of n. And I think we changed n to go from 0 to 110 by 5, so that's 22 steps. I'm going to go fast, so you're free to ask a question and stop me. Okay? So this was what we were doing. Okay? So what's the meaning of this? I typed in A35, it gave me 50.56. You should know the meaning of that. It's the expected attendance if the temperature was 35. This was one of yours. You should know the meaning of this. This is really important to look at function notation, especially a difference. What's the meaning of that 8.6? If this is the attendance, it's kind of like the temperature starting at 25 and going up to 35. And we're looking at how much higher the attendance is. So it's 8,600 is the increase in attendance if the temperature would increase from 25 to 35. Is it equal to A10?
No.
So let me show that visually. But lots and lots of students will try to do this. Here I'm showing delta x of 10, or delta t. corresponding change in attendance. What is that value? The change in attendance. Or 8,600, right? 8.6. What is A of 10? So how could you represent on this graph A of 10? Let's ask somebody. Where's Andrew Myers? Andrew. Usually in the back. Not here. Okay, how about Rohit? How can I represent visually A of 10 on this graph? What would A of 10, a representation of A of 10 be? Okay, and so how could I show that visually? Expected attendance at 10 degrees, that's good. So here's 10 degrees. So how could I show the expected attendance at 10? Yeah, so I could draw a line straight up, like this. And so either that y coordinate or the length of this segment, right? Isn't the length of that segment A of 10? So I ask you, is A of 10 the same as A of 35 minus A of 25? Not only are the values different, the meanings are completely different. Here, it's exactly what he said. It's the expected attendance if it was 10 degrees, which is this much. This is how much the attendance goes up if the temperature increases from 25 to 35. Totally different. But because if you're not thinking about it, it's easy to say, oh, 35 minus 25, that's 10, so that must be A of 10. But you see that it's not the same. Really important. Okay, so we wanted to represent these changes. So we could say, if we wanted to show that change of temperature, we could say that's y equals whatever it is at 25. But we only want it starting at what? Starting at 25 and going up to 35, right? And then how could we represent, how could we get this line segment right here? That would be x equals what? That'd be x equals 35, starting at A of 25, going up to A of 35. Make sure you, I did that fast. Make sure you understand this really well. Okay? My hope was in this that you really use the function notation instead of getting these decimal approximations for these numbers and using those. Why is this? There's two reasons why this is better. First of all, these are exact values. The value represented by these is exact. You never have to round or know how many decimal places to take. The second reason it's better is because this shows the meaning of it, right? So if you just had a number there and you just were focused on that number, you might forget what its meaning is, but we know exactly what the meaning of A of 35 is. And this is so key in calculus that you can interpret the function notation and then you have the confidence to use it yourself. That's why we're practicing this. So now we want the roving. So the roving triangle, instead of just A of 25, we want, right? For any x value, we want y to be the expected attendance, starting at that temperature and going up to n plus 10. And so then where will that vertical segment be? At what x value? N plus 10, going from n to A of n to A of n plus 10. Right. Make sure you understand this, and you could create this yourself in a different situation. If I gave you a different change in x, a different function, okay, a different set of quantities, could you reproduce something similar? And then the very last part of it was that you have some difficulty here. over when you pass the maximum and the expected attendance starts going down, suddenly we lose that vertical segment. Okay? We still want that vertical segment to be 10 degrees greater than our starting point, so this is fine, the x of n plus 10. But this is problematic. Okay, so what's going on there? Okay, values are decreasing, so what? Why doesn't it show what's happening? So when it's decreasing, how does A of n, the first expected attendance, compare to the later expected attendance if it's increasing?
After you pass the max, the inequality isn't true anymore because the first part is greater than the second part.
Yeah. So if we have a decreasing function, here we have a function value. If we take another function value down the road, it's going to be less, not greater. And this is saying all the y values between this lower bound and this upper bound. But this is less than this now, because the function is decreasing. So to fix that, this is our lower value now, right? The later value is the lower one. We want all y values up to the greater. So over here now, this last line, the purple one, is invoked, but then over here, the middle one is invoked, because here it's true that A of n is less than A of n plus 10, but over here, A of n plus 10 is less than A of n. Okay, make sure you get that. Make sure you understand what's going on here, why we needed that extra line to do that. Anybody have a question? Really important. Everything about this.
So when you say make sure we know how to do it, just make sure we can explain it. It's like on the test you showed us that. We need to know the difference between the top and the bottom, or are we going to be...
There's a dozen ways I could test your understanding of this. So in a different situation, could you create it? Could you look at command lines like this and interpret them correctly? So anything. Yeah, anything. Yeah, Tyler.
With the ones that I did, my triangle ended up on the opposite side of the curve.
Okay.
On both ends.
Okay.
So I had the x of equals n, where a of n is less than y, which is less than a of n plus 10.
So yours looked like this,
Yes.
and then over here it looked like this.
Yes.
Okay, it's okay. The advantage to the way I'm doing it is, usually when we think about changes, we take the change of x first. We do a change in our independent, and then we look at the resulting change in the dependent. So that's what this communicates, right? You're starting at this point. What comes first? Change in the input, and then the resulting change in output. So it's okay, but just know that this is why we do that. It's the change in input comes first, then resulting change in output. So yours would be change in output first, then change in input. You see? Okay. Other questions? Okay, let's talk about more constant rate of change. So let's summarize. I was going to give you another quiz, and I think from here on out, at the beginning of class every day, I just had a bad situation this morning. That's why I was late. But from here on out, I'm gonna test you on these little basics on constant rate of change. Every class, we're gonna have the same quiz on constant rate of change. So let's summarize it right here. So I want you and your partner just to take like 1 minute. See how many different implications you can come up with. We've been talking about constant rate of change, and it has different meanings or different things that are true if you have constant rate of change. So with your partner, see how many things you can come up with, okay? 1 minute, go. See how many different implications you can come up with, and then I'll put them up and you see how many you got, okay? Go. Did you get them all?
So you know the quantity of
Peter. Haiti? Haiti? Haiti. Name her. That. Tyler. Beth. Thank you. Okay. The first thing, kind of the main definition was changes in y are proportional to changes in x. Did you get that one? Okay, good. And if that's true, then what's true about any change in y? Any change in y can be calculated how? Is it equal to the change in x? Every change in y is a constant multiple of its corresponding change in x, or y equals k delta x. This is probably the one that's gonna come up the most. We're gonna see it like 4 times as we're building up the calculus. We're gonna come back to this over and over again. So not only do I want you to memorize it, but be on the lookout for it. We need a change in y. We need a change in our output variable. How are we going to calculate it? If it's constant rate of change, it's k delta x. Okay? Next one is relative size. Every change in y has the same size relative to its corresponding change in x. Remember that? Here's that. The change in y over change of x is a constant. Okay? This is the relative size. Remember the bars. Remember that? That's not great. Relative size. The relative size remains the same. Okay? Next. This is an important one. Did anyone get this one? The y value always changes k times as fast as x changes. Okay, so we'll talk about that one as we look at some examples. That's really important too. That y is changing, always changing k times as fast as x. And that k is our constant rate of change. That's our constant rate of change. Here's another new one. Any equal change in x results in an equal change in y. So if you pick a change in x, and you apply it in different places, what's going to happen? What's the change in y going to be? You're going to get the same change in y every time. And then x and y will be a linear relationship. Okay, so you see how much there is to constant rate of change. Constant rate of change is the bedrock of calculus. It's the bedrock of calculus. We have to know it inside and out. That's why we're doing all these little reflection assignments to really think about it. Any questions on those? So let's look at the spruce trees, the spruce and the cedar trees. Okay, my spruce tree grew 14 feet, while my cedar tree grew 11 feet. They grew at a constant rate with respect to each other. First question, what are y and x in this statement? So what quantities do y and x represent? So
Y would be this.
y is a tree. Is y a tree? A tree is an object. We need a quantity, right? Y equals height of what?
Height of this.
Of the spruce. Does it say in feet? In feet. Okay, so then therefore x is height of the cedar, also in feet. Did the tree start at the same height? So this says my spruce tree grew 14 feet while my cedar tree grew 11 feet, and they grew at a constant rate with respect to each other. Did they start at the same height? Someone says no. Anyone say yes? Anyone say something different? Did they start at the same height?
I don't think it really specifies because it just says the one grew 14.
You don't know. Maybe they did. Maybe they didn't. It just says how much they grew simultaneously. They could have been the same height or maybe not. But then we know that just how much they grew. We don't know. Okay? What's delta y? What's delta x? And what's k in this statement? So if y is the height of the spruce tree, what is delta y in this statement? Okay, and what is it? Yeah. He wants 14 feet. Delta y. The change in the height of the spruce tree. Agree? Absolutely. What's delta x? Change in the height of the cedar. Okay? What is k? The relative size of changes, right? The relative size of the change in the spruce tree relative to the change in the height of the cedar tree. Okay, when my cedar tree grown 2 feet, my spruce tree grew 2/11 of 14 feet. So when my cedar tree grew 2/11 of 11 feet, my spruce tree had grown 2/11 of 14 feet. Whenever my cedar tree grew 2 feet, my spruce tree grew 2/11 of 14 feet. So this is getting back to a principle we saw way back at the beginning of the course. Okay? So what are delta y and delta x in this statement? So let's start with delta y. What's delta y? The change in which tree? The height of which tree? Spruce. How much? 2/11 of 14. Change in x? 2 feet. Are we good? Yeah, so change in y, if y is our height of our spruce tree, the change in y will always be the change in the height of the spruce tree. And if x is the height of the cedar tree, a change in x will always be the change in the height of the cedar tree. And that's what this says, okay? Okay, why is it important in this example to observe that 2 is 2/11 of 11? So what's really going on here? Before, what was our change in x before?
14 feet.
The original change in the cedar tree was 11. What's the new change in the cedar tree? 2. So, what is 2/11? So why is it in this example is it important to observe that 2 is 2/11 of 11? what's happening here? We've got this change of 11, and then now in the cedar tree, and now we're saying the cedar tree grows another, say, another 2 feet. So what's this 2/11ths? What's this about? In the back.
It's just showing that they're both growing at a constant rate.
But we're only talking about the cedar tree here, right? They're both cedar tree changes. Yeah, Josh.
Could it be that like at one rate, like when it was constant at one point, we only amended, but we're taking it up until like if we were only 2 more instead of just like 4/11.
Okay. So where's the 2/11ths come into it? Judith?
So it's like 2/11ths of the 11-foot tree, and because you know they grow at the same rate, that's why you have to know that it's 2/11ths for that one, because it'll be 2/11ths of 14 for the other one.
Okay. What is this number 2/11ths really? We talked about it before. Say it louder. It's a scale, right? It's a scale. We had this old change of 11, and now it's like we're scaling that change to be a different change of 2. It's all about the cedar tree. We're not even talking about the spruce tree at all. Okay? So we're scaling the change in the cedar tree from an 11-foot change to a 2-foot change. So if we have constant rate of change, then what happens with the original change of the spruce tree was how much? 14. So what will the new, if we look at a scale change of the cedar of 2/11ths of the old change, then what will the new, it's going to be, we need the same scaling factor on the change in the spruce tree. So this is this is another consequence of constant rate of change, that you have scaling factor reasoning. If you scale one change by an amount and then it's in constant rate of change with another quantity, the other quantity's change has to be scaled by the same amount. That's multiplication times 2/11ths. Okay. So then let's look at this fish one. Any questions on the trees? Okay, actually I want to look at something different. Here's our attendance function. Is temperature and expected attendance, do they have constant rate of change? I hear most people saying no. So give me one justification why attendance and the temperature and expected attendance do not, just one justification. Imagine. Okay, so he took the easy one. He stole the easy one, right? It's not a linear graph. Okay, how about a different one? Yeah.
The triangle changes size.
Okay. So which are you
The height changes on the triangle.
what's the key word, right? The height is changing.
Not at a constant rate.
Yeah, so we don't have relative size maintained, right? Here, how does delta y compare to delta x here versus here? What's the relative size of delta y here compared to back here? Less or greater? Less. The relative size is much less here of y than it is here. Okay, another reasoning why this is not constant rate of change. Look at number 5 in the list. Did you write down the list? Equal changes in x. How am I showing that that's violated here? That equal changes in x are not resulting in equal changes of y? Yeah. Yeah.
Y has bearing.
Right, so I'm showing a change of 10 degrees in many places. If it was constant rate of change, the corresponding change in y would have to be the same. But clearly, for a change of 10 degrees, the change in y is different. Okay? Right, so we can talk in many ways about the same situation in all these different implications of constant rate of change. Any questions? So where's that list? Put that back up. No, not that one. Any questions about the exam? Constant rate of change, graphing calculator? Let's talk about getting help. So today, you've got office hours? What time? 12:30 to 2:30. Tomorrow, he's 12:30 to 2:30, I'm 2:30 to 3:30. Okay, so study hard, make your list of questions and things you need to talk more about. So figure out what you don't understand, get to one of us, and get the help you need before the exam. Okay? Cool.
Can I look through here and get my homework back?
Oh yeah, I've got homework. Today's homework to get back to you to help you study. DJ. CZ. CZ. Stanley Levinsky. Yes. Zoom. Zoom. Richard Martin. Marcus. Judith. Julius. Lindsay. Gordon Ryan. Leon. So. Z Wang. Come on up to your homework. Savannah. Sorry, Sharon Wood. Christina Zambrano. Stephanie Sandoval.
Two of my best friends.
Daniel Schweitzer. Jude. Corey. C. Lee.
I don't remember that.
Daniel Schweitzer. Richard Martin. Daniel. Okay, questions?
Yeah, I actually
That's what I was thinking.
I'm having to go out of town for a couple of days, so I needed to know what I needed to do as far as
No.
whatever place
Yeah, so you can submit homework at small and submit before they're due. They'll all be on afterwards. Watch videos and practice watching videos. How many days was that? Right.
Okay.
Yeah, just let me know like the day before you're done. And I'll know where we're at.
I can just like
I'll
stop
be
it.
able to do homework as long as there's an
Do the homework, watch the videos, and just stay involved.
I was wondering if there was any way to be able to do the homework in advance, like start
Do the homework
what
again.
it's gonna be before I leave.
Can't really, I don't really know that far in advance.
As I said,
because the days
myself,
sometimes change.
Everybody else is fucking on the
Because what
same
we're gonna get
It'll
to
just be
after.
like a Wednesday.
Just talk to me that Monday and I'm gonna be able to give you some better indication.
The reflection on the blackboard that you posted, I remember that I wrote it somewhere in my notebook and I couldn't find something in the Zoom. So is there any way that I can, I don't know if I can go find in my room?
No, you just gotta just take one here and just remember to bring everything for the whole
Yeah, I mean, I thought it was on my notebook, so I was pretty okay with it, but
Alright.
I couldn't find it. So
Sorry.
there's nothing that I can
Yeah,
do.
so I'll definitely be dropping some at the end of the semester. So it'll just be, if this is one of your lowest, it won't affect your grades.
Okay.
Okay.
Fine, thank you.
Alright. Who else? Let me turn the video.